A couple of the matching questions, starting with question 13. In this case, we have a rational function, rational because it's a fraction with a polynomial in the numerator and a polynomial in the denominator. And we're first asked for vertical asymptotes. To find those, we look at the denominator. I present it here in factored form, so they're easier to spot. If you put a -1 here, -1 plus 1 is 0. 0 times anything is 0. That places a 0 in the denominator. And so that means that at -1, at x equals -1, we have a vertical asymptote. Similarly, if you place a 2 here, 2 minus 2 is 0. Denominator is 0. And so we have a vertical asymptote at x equals +2. Then, in the next part, we're asked whether there's a horizontal or an oblique or slant asymptote. You can't have both. You can only have one or the other. So the degree of the numerator is the same as the degree of the denominator, and that means we will have a horizontal asymptote. So I've checked or crossed here the box to indicate we have a horizontal asymptote. What is that horizontal asymptote? To determine that, we place the leading coefficient of both the numerator and the denominator, as I've indicated here, in a fraction and simplify. Leading coefficients are 1 and 1, and 1 over 1 is 1, so at y equals 1, we'll have a horizontal asymptote. Next, we look for the zeros, or the x-intercepts of the function. And for that, we look to the numerator. Well, again, if we put a -3 here, -3 plus 3 is 0. Or if we put a +1 here, 1 minus 1 is 0. Either of those will make the numerator 0, making the entire function value or y value 0. So we have x-intercepts, or zeros, at x equals -3 and x equals +1. Finally, the y-intercept is found by substituting 0 in for x in the function. 0 here, 0 here, 0 here, and 0 here. And as you can see here, that leaves -3 over -2. And a negative over a negative is a positive. And so the y-intercept occurs at 3/2. 3/2, of course, is 1.5, so we'll look for that on our graph. Now we go to the graphs and look for graphs that have vertical asymptotes at -1 and +2. So our rational functions are here. The first two have slant asymptotes, so we know that those are not the matching graphs. So we move on to the next pair. This graph, graph S, has a slant asymptote, so we know that it's not that graph. This one has a horizontal asymptote at 1, so we'll keep that in mind. This one, T, has a horizontal asymptote at 1, and so we'll keep that one in mind as well. And finally, this one, graph U, has horizontal asymptote at 1, and so we'll keep that one in mind as well. So what's the difference between these? Well, next we look at the vertical asymptotes. Where were those? Those were at -1 and +2. So this one has asymptotes at -2 and +1. So it's not that graph. So we have to come down to these two. And we see that they both have vertical asymptotes at -1 and +2. So now we have to look at a couple of other indicators. The y-intercept. Well, the y-intercept to this one is 3. The y-intercept to this one is 1.5, which is 3/2. So we're pretty sure that T is the matching graph. The x-intercepts are at -3 and +1, and so that seals it. That tells us that yes, t is the matching graph for this function. So I've indicated that here. Next, we'll move on to number 14, another rational. Vertical asymptotes are zeros of the denominator, -1 and +1. And there's a slant asymptote because the degree of the numerator is exactly 1 greater than the degree of the denominator. So that tells us there's a slant asymptote. The x-intercept is +2, because +2 minus 2 is 0, and x squared plus 1 cannot be factored. So we have only one x-intercept, only one 0 at x equals +2. And finally, the y-intercept is 2, because when we substitute a 0 in for all the x's, we get -2 over -1, which is the same thing as +2 over +1, which is 2. So now we come to our graphs. We come to our graphs and see which one has a slant asymptote, and let's see, vertical asymptotes at -1 and +1. So this graph, P, has vertical asymptotes at -1 and +1, and it has a slant asymptote. So it's a possibility. This one has a slant asymptote, and it has vertical asymptotes at -1 and +2, so it's out. This one, graph R, doesn't have vertical asymptotes in the right place. This one, graph S, does have vertical asymptotes at -1 and +1, and a slant asymptote, so it's a possibility. And again, T and U have horizontal asymptotes, so they're not possible answers. So finally, we look at the x-intercepts and the y-intercept. Well, both P and S have an x-intercept at 2, which is what we're looking for, but only P has a y-intercept at +2, as opposed to this one at -2, so we know that P is the graph that matches that function.